Hello everybody, and welcome to another video on mathematics. And in this video, we will be looking at variation. And at the end of this video, you should be able to do two things. You should be able to perform operation on the direct variation and inverse variation. So let's head into the meat of this video. So first things first, let's understand what we mean by variation. Now, variation refers to how one quantity changes in relation to the other. And in CSEC mathematics, variation often appears in two forms. Firstly, direct variation, which is sometimes called direct proportion, or inverse variation, which is sometimes called inverse proportion. Now let's look at direct variation, or sometimes it's called direct proportion. So in direct variation, as one quantity increases, so does the other quantity. And this is done at a constant rate. And this relationship is expressed as seen here. So this part is saying y is directly proportional to x, or y varies directly as x. That is what this part is saying. And this, as an equation, is equal to y is equal to kx. Now k is a very, very important constant, as you will see in just a few seconds into this video. So let's look at how we deal with questions involving direct variation. So first of all, we identify the constant of proportionality, which is k, using the given values that you will have in the question. And after you finish finding that k value, which is important, that is the first thing you should find, you then use the formula y equal kx to solve for the unknown. So step one, you find k. Step two, you use k to answer the question. So let's look at an example. So the example says, y varies directly as x. Now when x is equal to 4, y is equal to 24. So they want you to find the value of k. So first thing, we need to represent this here as an equation. Y varies directly as x. So to answer A, we'll write that as, so y varies directly as x, as we saw in the previous slide, is equal to y is equal to kx. So first thing we need to do is find the value of k. So in order for us to find the value of k, we must use the values given for x and y, and then use that to find k. So it says when x is equal to 4 and y is equal to 24, find k. So we use these values, first of all, these values that they give us, and we find what is k. So after we find what is k, they said that k is a constant, so that means k would not change. So let's find k. So we see y is 24, so 24 is equal to k multiplied by x, which is 4. So to solve for k, we take over the 4. So the 4 is multiplying. When we take it over, it will divide. So we'll have 24 divided by 4 is equal to k. So we see k will be equal to 24 divided by 4 would give us 6. So the constant of proportionality will be 6. So k is equal to 6, and that will not change for this question. K is a constant. That means as long as you find k, you don't have to find back k ever again. So now they want us to find the value of y when x is equal to 10. So we use the same equation. So part B, we use the same equation. Y is equal to kx. So we know that k is equal to 6 that we just found. They want us to find the value of y when x is equal to this. So y will be equal to k, which is 6, multiplied by x, which is 10. So y is equal to 6 times 10 is 60. So when x is equal to 10, y is equal to 60. And that is what variation tells you. When one thing is equal to something, what is the value of the other thing? So let's move on to inverse variation or inverse proportion. So in inverse proportion, as one quantity increases, the other decreases. So this is the inverse to direct proportion. So as one increase, the other decrease. So this is following the relationship. So this is what this part of this is saying. Y is inversely proportional to x. Or this is represented as y is equal to k over x. So K, once again, is a constant of proportionality. So just like with direct variation, when we have a question for inverse proportion or inverse variation, we must first find the value for K. You always have to find K first. So let's look at steps in solving inverse variation. So step 1, we identify the constant of proportionality, which is K, using the given values. So just like in direct variation, we use the values that we are given and we solve for K. And then we use the formula to find the unknown values, whatever value they ask you to find. So let's head into a question. So this question says, y varies inversely as x. So when x is equal to 5, y is equal to 12. And they want you to find K. So y varies inversely as x. So to answer the question A, we first write down the equation. So y varies inversely as x. So this will be K over x. And this is the equation to represent the inverse variation. So they said when x is equal to 5, y is equal to 12. So we solve here. So we see y will be 12 is equal to K over x, which is 5. So the 5 is divided. When we take it over, it will multiply. So we'll have 12 multiplied by 5 is equal to K. So K will be equal to 12 times 5 would give us 60. So the value of K, the value of the constant of proportionality is equal to 60. So K is equal to 60, so 60 would not change. The value of K would not change for this question. So now we can use that to answer the second question, which says the value of y when x is equal to 8. So first of all, to work out B, we put down the equation y is equal to K over x, and we put in the values that we know. So we know y is what we want to find. So they said that when x is equal to 8. So we know K is 60, so this will be 60 divided by 8. So when we work this out, y will be equal to 60 divided by 8 is equal to 7.5. So the value of y when x is equal to 8 is 7.5. So as we can see, as x increases, y will decrease. So let's look at some practice questions to cement our understanding. So let's look at the different forms in which this question can come. So this one says, y varies as the cube of x. And when x is equal to 4, y is equal to 10. Find the constant of variation, which is K. So let's answer A. So for A, we see we need to write down the equation. So this question says, y varies, so y is equal to, inversely, so we know it's K over the cube of x. So we see x has to be cubed, so x raised to the third power. So to find for K, we put in the values that they give us, which is x equal 4 and y equal 10. So y is equal to 10, so this will be 10 is equal to K over x raised to the third power, which is 4 raised to the third power. So 10 will be equal to K divided by 4 raised to the third power will give us 4 times 4 is 16. 16 times 4 is 64. So to solve for K, we take over this 64 and we'll multiply the 10. So 64, so 10 multiplied by 64 would give us K. So hence K will be equal to 10 times 64 will give us 640. So the constant of proportionality, or K, is equal to 640. So B, they ask you now to find the value of y when x is equal to 5. So we already know K is equal to 640. Now let's use that value for K and solve for y. So we put back the equation. So y will be equal to K over x to the third power. So y will be equal to K, which is 640, divided by 5 raised to the third power. So y is equal to 640, all divided by 5 raised to the third power, which is 125. And when we divide 640 by 125, we'll have a value of y is equal to 5.12. So when x is equal to 5, y is equal to 5.12. So in this question, we saw we had to do a slight change to the formula, a slight change to the equation. So y varies inversely as the cube of x. So we saw that we had to add a cube to x. So let's carry on with another question. So this one says, the pressure P of gas varies inversely as its volume. So if P is equal to 40 and V is equal to 20, find P when V is equal to 25. So this is a worded problem. So we see the pressure P of gas varies inversely as its volume. So let's write an equation to represent that. So we see P varies inversely. So P is equal to K over volume, which is V. First thing we need to come up with is the equation. So P is equal to K over V because it varies inversely as its volume. They want you to find P when V is equal to 25. So firstly, we must find what is K. They did not ask us to find for K, but we have to find for K. So we put in the values that we know for P and V. So we see P is equal to 40, which is equal to K over V, which is 20. So the 20 is divided. When we take it over multiplies, we'll have 40 multiplied by 20 is equal to K. Hence, K will be equal to, so 40 times 20 will give me 800. So K is equal to 800. So K is equal to 800. So now that we know the value for K, we can use that value for K and find for P when V is equal to 25. So we know P is equal to K over V. So in this case, we want to find for P. So P is equal to K, the thing that we just found, 800 divided by V, in this case, which is 25. So 800 divided by 25. So P will be equal to 800 divided by 25 would give us 32. So to answer the question, when volume is equal to 25, the pressure of gas is equal to 32, based on the working for this question. So this has brought us to the end of this video. So let's just summarize the key points. So first things first, we must identify the type of variation that is happening. So if it's a direct variation, we know the formula will be y is equal to kx, or whatever variable you use. And if it's a direct variation, but you have to make some adjustment, just look out for those adjustments. Sometimes it may be y varies directly as the square root of x. So we know that will be y is equal to k multiplied by the square root of x. And if it's an inverse variation, the formula is y is equal to k over x. If the statement says y varies inversely as x, or sometimes there's a little adjustment to x, or whatever variable they use. So sometimes if they say y varies inversely as the square of x, we know it will be y is equal to k over x squared. So sometimes they use letters and variables such as a and b. So we can have a varies directly as b, so which will be a is equal to k times b. Or we can even have m varies inversely as the square of n. And we know this will be equal to m is equal to k divided by the square of n, which will be n squared. So I trust that you now have a good understanding of variation. These questions tend to come very often in CSEC. And with that, I'll leave you some questions to practice on your own to test your skill on variation. So good luck with them, and I'll see you in the next video.